belongs to Z2. So the only difference is that I'm replacing R2 by Z2. So this is in which space you work. If you are working in your calculus is all done in R2. Now I want to do the same thing in Z modulo 2. Means this is another framework. And then if I am right, so in my first lecture, I came up with a very nice example of a polynomial, right? A naught plus A1x plus etc. an minus 1 xn minus 1 plus an xn, and then allowing a1, a naught, an belonging to, suppose I take these coefficients as numbers, then I say that if it is coming from integers, then this polynomial expression is defined over this integers. For example, if I write f of x is equals to 1 plus 2x plus 3x squared plus 5x cubed, then my polynomial is said to be defined over integers because my a0, a1, a3, etc. 5 are all integers. Okay? The idea is I have to, my computer has to handle these things. I have to feed this into the computer. Okay? When I add two polynomials, the way just we are told to add, my computer should be able to do that. And then for that, so I want this to be stored in the computer, in a computing device, so that it will, whenever you give a command to that, pick the polynomial means, the computer will look for the polynomial, and what is to be done from that? See, the next level is that only after numbers, you get into polynomials, and then start doing arithmetic operations on polynomials with manipulations and all that, and then start solving the equations. That's the thing. And just like in the case of arithmetic, where you have numbers, so these polynomials are handled. Okay? And so there is an interplay between these examples with the concrete examples as algebraic systems with the well-known examples of continuum. So when the Raman was telling combinatorial structures, okay, exactly these are combinatorial aspects of that. Now, I call this as a space, and this is known as a vector space. A vector space over Z modulo 2. I'm very specific about this. Or I will do this for that. Instead of arbitrary n, I will take a prime, P prime. P prime. So is a vector space over Z modulo P. This is very interesting. Why you are interested in primes? Why people look for primes? Why anybody wants to know, given a very large odd integer, whether it is prime or not? This is all about primary testing. Just like you go to a doctor, then he would prescribe tests. Blood test, urine test, then after class, before, then later on, come up with all those CT scanning and all those. These are all tests. You know? So there are certain criteria should be followed, and then I have to pass all those tests. Then there are parameters fixed for these things. And then once those test results come, then the doctor will be able to go through the results and then say that, okay, you don't have diabetes, you are prone to this, your heart is functioning well, brain is good, kidneys are working fine. Means all those tests, when done on an individual, they're passing those tests. So that kind of a thing you will see here. Probability testing is exactly that. Given a number, whether it is prime or not, once you decide that it is prime, you catch hold of that number and then construct a vector space over the prime. So for each prime B, I can construct a vector space because vector space are very important. In linear algebra, you are told about them. The differential equations, linear systems are all solved with the help of this vector space structure. The other structures are also there, but let us not bother with them. Let us see for ourselves the importance of prime. Why we should be interested in this decidability of the problem, whether the given number is prime or otherwise it is not prime. Okay. Because I have seen that you start with 2, the moment you get 4, you write it as 2 raised to 2, then go ahead, you will get 2 raised to 3, 2 raised to 4, etc. etc. So, it is true with any prime P, only even prime is P is equal to 2, the rest are all odd. And therefore, you look for P, P square, etc., P raised to K, for sufficiently large K. These are called prime powers. So any big number, if I can express as the product of prime powers, okay, for example, 1024, I did not write 1024 as something like this. It is 2 raised to how much? 2 power 10. 2 power 10 is 1024. So useful here. You are saving the space of the computer and then you are storing a 4-digit number into like this. And so this is prime raised to some power. Now there are some results in number theory. I don't know whether students have studied number theory in their undergrad program. We had one course on number theory during our time. Did you study number theory? Okay, that's good. So there we have some important theorems. One is called as Wilson's theorem. This Wilson's theorem gives a very strong condition for a number to be prime. If I am right, if I recall m minus 1 factorial, see, the point is organizers are giving you only instruction. You do wherever you want to do corporations. For mathematics, ensure a blackboard. You keep it in jump and shandy, I don't bother. But let there be a blackboard. Okay? What is this Wilson's theorem? Wilson's theorem says, if I remember, m minus 1 factorial congruent to minus 1 mod m. If this criterion holds, then you can declare m as prime. If only if business. This way, it holds. And so you have got prime. For example, you take 5. 5 is okay. 5 is prime. 4 factorial congruent to minus 1. Congruent to minus 1 mod 5. Check it. What is factorial 4? 24. 24 plus 1. 24 plus 1 congruent to 0, not 5. So this is Wilson's theorem. The problem with this is computing factorials is a bad, the complexity is very high. I didn't know this. I didn't know this. It's incredibly if. I knew only if. But it's both ways, it's okay. Alright. Then comes your a very interesting theorem. What is that? Fermat's little theorem. Okay? What is this Fermat's little theorem? I'll go back. You can try this. You take any integer. Okay? If your brain accepts bigger and bigger, extremely fine. Otherwise, this theorem is a witness to that. Okay. Now, since I said that, so I'm putting the number to a test for primality, and therefore, so we have prime numbers and then in the list I have, this is a bucket list, okay? In that you have co-prime numbers and then they call it as pseudo primes. So sometimes doctors give us a multiple test, why? In some tests, I pass that. But final test they will be there, that will be very strict. There will be caught. So this is how the pseudo primes come. Okay. So what is your Fermat's little theorem? So I go by Fermat's little theorem. It's not really little, it's very big theorem. So very big result. Okay. And if I look at these things, the decidability is, binary is either n is prime or n is not prime. They call this as a composite. If it is not prime, then they call it as composite. Okay? 2 is